Greetings, students. Today we're going to discuss Test 2-3 review. Let's begin. Question 1, the distance between the points. So from 0 to 1, that's up by 1. From -5 to 3, that's up by 8. My distance will equal the square root of 8 squared plus 1 squared, which is going to be 64 plus 1, or 65. Again, you're looking at how far the items are apart. 0 to 1 is 1 apart. -5 to 3 is 8 apart. We also have the formula on the board for you. Distance formula, you can use that as well. Alright, point slope form. Y minus y1 equals m times the quantity x minus x1. So the y1 and the x1, these subscripts mean replace me with a number. This means replace me with the y value. Replace me with 2. Y minus 2. Again, the y we don't replace. It's not a subscript. It's not supposed to be replaced. The m always was replaced. It's a slope in every formula for mathematics. Other formulas have different things for m. So we always replace it with slope. If it's given, we put it in. If it's not given, we find it. In this case, it's given, -7/2. Times the quantity. Again, x is not replaced. The subscript x is replaced. X sub 1. That's what it means to be subscript, to be replaced. There we go. Alright, last week on the test, somebody had trouble with this question, these two questions. Corresponding again means same spot. So if I'm looking at this, these are not in the same spot. This is in the upper left corner, this is in the bottom right corner. Same thing here. This is in the upper right corner, this is in the bottom right corner. Upper right, bottom right, not the same spot. Alternate exterior means they're both outside the lines. So exterior of the lines is above and below them. Neither of these angles is exterior. On question 4, x is exterior, but y is interior. So neither of these is exterior, alternate exterior. Same thing applies to consecutive interior on this question here. X is not interior. Now, here they're both interior, but they're not consecutive, they're alternate interior. Because they're alternate sides of the transversal, left and right of the transversal. So this is option B, alternate interior. For it to be consecutive interior, the X would have to be here, or the Y would have to be here. They have to be on the same side of the street. Both on the left of the street or both on the right of the street, inside the lines. Alright, that leaves us with vertical and adjacent. Vertical again is across from each other, kitty corner. Adjacent is next to each other, sharing a line or ray. In this case, these are adjacent because they share this ray right here. This ray right here is shared between these two angles, y and x. Also, they are supplementary on this diagram. Adjacent angles are also supplementary. Option F. Again, there's 6 different options I can choose from here, so don't think I'm just going to choose these 2 like some of you did last week. I'm going to choose 2 of the 6. So I'm on the test, I might choose an entirely different 2, like corresponding and vertical, just like I did last week. Alright, 5 and 6. Decide which of these is supplementary and which of these is equal. That's what you need to do on these questions. I'm going to do one of each. So on number 5, number 6, what do you think? Number 6 is equal. Number 5 is supplementary. So on number 5, let's add these together. Well, 12x doesn't add with 70 because they're not like terms. But -10 and 70, they do add and they make a positive 60. They actually subtract because they're opposite signs. Equals 180. 60 from 180 is 120. Very easy to divide 120 by 12 because that's 10. So I took 60 from 180 here to get the 120. I'm going to divide by 12 to get the 10. Here we got equality. So I'm going to take 66 from 55. This is going to yield a negative answer. Why negative? Because the 66 is bigger than the 55. X is -11. Or the opposite of 11. Alright, question 7 and 8. Same question as last week. Some of you still missed it. I'm looking for the definition of parallel in high school. Not the 3rd grade definition. I don't care that the lines never cross. I really do not care that the lines never cross. What I care about is that the slope is the same. Same slope. All you have to do is rewrite this number right here. Rewrite the number right there. That's all you have to do. The slope of a line parallel is the same as a given line. This is the high school definition of parallel. Alright, perpendicular, same thing. I'm looking for the high school definition of perpendicular. I don't care that they meet at a right angle or that they form an intersection. What I care about is that the slopes are negative reciprocals. So you flip this 5/2, you take this and you flip it and you change the sign to a negative. If it's a positive. If it was a positive or if it was a negative, I change it to positive. So 5/2 becomes 2/5 and it's now negative 2/5. If you're having issues with this, you can make a grid, a coordinate grid, and you can plot two slopes that are the same. You'll see that they never cross, and then two slopes like this, negative reciprocals, you'll see that they meet like an X at a right angle. Again, we want the high school definition of these words. We don't care about the third grade definition anymore. We really do not care about the third grade definition. Alright, classifications. So we have angle classifications: obtuse, acute, and right. This week I'm not going to tell you what the names are. You're going to have to remember them. So this is acute. The angle is all between 0 and 90. This is obtuse. There's one angle bigger than 90, less than 180. In other words, one angle between 90 and 180. Side names: scalene, isosceles, equilateral. This, all the sides are different. This is scalene. This is also scalene. All the sides are different. Equilateral would be all three sides the same. Isosceles would be two equal sides, which are both scalene. All different sides. You need both words: the angle name and the side name. Right, every triangle makes 180. So this triangle will make 180 as well. 29 and 72, that's 11, that's 101. Taken away from 180 is 79. That question mark is 79. This is the exterior angle theorem. You can do the 180 theorem here as well. 35 plus 75, subtract from 180, is going to yield, what is that, 110, that's going to yield 70. And then 70 subtract from 180 is going to yield 110. Or you can do the exterior angle theorem here. Question mark is exterior to these two. So 75 plus 35 will equal that question mark, 110. There's a short way to do it. Again, the longer way: 35 plus 75, 110, subtracted from 180 is 70. Subtract 70 from 180 to get 110. Alright, there's only 24 questions this time, so we're going to do 4 points each. Alright, I can get partial credit on the ones here that aren't multiple choice, so everything but numbers 3 and 4 I can get partial credit on, and 7 and 8. 7 and 8 I can't get partial credit either, because they're just right or they're wrong. There's nothing we can do on those two. The rest I might get some partial with. Alright, question 13, not 3. Let's go with purple pen here. Still the same thing as the question on the front. Every triangle makes 180. So take 25 plus 135 plus x plus 2, that's equal to 180. So maybe I'll set it up this time like this. X plus 32 plus 25 plus 135, adding it all up. So that's 5, 10, 12. That's 3, 5, 6, 9. 192. X plus 192 is 180. 192 taken away from 180 is my answer. So again, I'm adding those up to be 180. So 192 taken away from 180 is negative 12. You can very easily check your work. This angle is 25, this angle is 135. That's a total of 160. So this angle has to be 20. Negative 12 plus 32 is 20. Right here, This is the exterior angle theorem. You need to use the exterior angle theorem here, otherwise you're going to do a lot of work. Take 2x plus 14 plus 37. So 2x plus 14 plus that 37. There's 11. There's 51. 2x plus 51 equals this angle outside the exterior angle. 5x plus 15. And here I would probably take the 2 from the 5x. Why? Because that way I'm dealing with positive numbers instead of negative numbers. If you want to deal with the negatives, move the x's to the left. That's fine. Then I'd take the 15 from the 51. That would be again positive. That's why I put the x on the right here, and that's why I'm moving the x to the right. So that is 36. And then dividing by 3 will yield my answer. X is 12. Alright, isosceles triangles, the base angles are congruent. So these are both across from the same marking. Same marking. X equals 50. This one's set up differently. This 55 is across from the mark. This angle is the same as 55. So X is not 55. This angle is 55. So it's got a similar setup but different work. So this one, X is not 55. You're going to take 55 plus 55, and every triangle makes 180 when it adds together. So that's 10, that's 11, 110, 55 plus 55, taken away from 180. 70. X is 70 here. The vertex angle is 70, in other words. We could also think of it as double the 55, subtract from 180, if you want to think of it that way. Alright, question 17. I highly recommend on questions 17 and 18 you ignore the pictures. I included the pictures because they're always included with these questions. What I recommend you do with these two questions is you have a look at the statement above. The statement tells you what's equal to what. So what does this say? I want I. What does it say that I is equal to? I is equal to which letter? T. I and T are in the same spot. Angle I is equal to angle T. Simple as that. You don't have to use the picture. You can use the picture if you want to look at this little marking here. Angle I's got a single mark, angle T's got a single mark. But it's much easier just to look at the statement above. K and L. K, L. What are they in the same spot as that? As up above. So here's K and L. K and L, they're in the same spots as R and P. Sorry, P and L. K and L is equal to P and L. There you go. Pretty quick. Alright, the next one you have to use the picture. So on the left-hand triangle, let's just look at the left-hand triangle here for a minute. FDE, or EDF, you can do either order. So triangle EDF is equal to, congruent to, triangle, which angle is equal to angle E on the other triangle? Angle R, it's got the same amount of markings. E is equal to R. D is equal to Q. And then E is equal to F. Notice here that E is not equal to E. There's two different E's. One on the right triangle, one on the left triangle. There's two angles at E. One of them is equal to F. The other one is equal to R. Alright, this one. JKL. I'm trying to keep it alphabetical on the left-hand triangle. You do not have to do that. Is congruent to or equal to. J is equal to R. This one has 2 marks, this one has 2 marks. R. K is equal to Q. Q. L is equal to S. Again, how do I know they're equal? Because of the markings. This has 1 marking, this has 1 marking. Therefore L is equal to S. This has 2 markings. This has 2 markings. Therefore J is equal to R. This has 3 markings. This also has 3 markings. Therefore, K is equal to Q. Check the markings. Alright. The triangle congruence terms we've talked about so far. We've talked about side, angle, side. Side, side, side. Angle, angle, side, and angle, side, angle. Look at the markings, see which one is listed. There's 3 that are easy to identify. The 4th one is not as easy. So let's look here on the far left. All 3 sides are marked. 3 side marks. 3 side marks. All 3 sides are marked. So this is side, side, side congruence. Side, side, side congruence. I did ask you if they are congruent. So identify if they are or not congruent. If they're one of these 4, they're congruents. What about this one? It's got 2 sides with an angle. Does the angle connect the sides? Yes. So both of these have 2 side markings, 1 angle marking. 2 side markings, 1 angle marking. The angle connects the 2 sides. Notice the angle is in between the 2 sides. That's how I know the side, angle, side. 2 sides with an angle that connects the 2 sides. 2 sides with an angle that connects them. Side, angle, side. Alright, this one. 2 angles with a side in between them. 2 angles with a side, or 2 angles connected by a side. Top and left angle connected by a side. This is angle, side, angle congruence. Alright, the final one here is missing a marking. The angle in the middle is shared. It's vertical. So we will add this marking. Why do we add this marking? Because we can. Because it's shared. Anytime you have a shared angle or shared side, you add a marking on it. So if on a test I had a set of triangles that was adjacent, like this, with a side marking here, and then an angle marking here, and an angle marking here, you could add the side marking in the middle because it's shared. This is shared. I would not mark this for you on the test because it's shared. You would mark it yourself. A shared side or a shared angle. A shared angle, again, is a vertical angle like this. That's a shared angle. So this is angle, angle, side. 2 angles with the side not connecting the angles. The side is not connecting them. It's not the side on the left here that connects the angles. It's the side above and below that does not connect the angles. Angle, angle, side congruence. I got 4 questions here. There's a good chance I'm going to use one of each. If I don't, then I'll be doing something tricky. Anyways, so 4 points each here as well. That makes it out at 96. I'll give you the last 4 for free. Come in after school today, before school tomorrow if you want to talk about it. Good luck.